Thank you, Dr. Wallen. Well, the first slide is quick. I have a couple more slides and a few little video clips that we will go to network and try to grab them and so on. So here's the first slide. I don't know how well you can see it. I'll try to
push that right hand one down as far as it will go.
This one? But people may fall asleep. It doesn't want to go.
Well, you're too excited for us to fall asleep.
No, this is just a nice little robot there. So, okay, that's sort of good. Okay, what you're looking at is a battle of the robots, the humanoid versus not so humanoid. And outlookers out there waiting to jump in on the action. All the toys. This one is Dr. De Palma's. That one is mine from a garage sale. These are people built them and we played with them a little bit and decided to have them somewhere. But nevertheless, we still have CSU-Pueblo all over the place, engineering. This has to be a little bit of a sales pitch. Now, I looked for this status of robotics around the world, and I couldn't find much except for a couple reports that came out last few years. The report on the world technology setup came in through George Becky and his group, and I knew some of those people. I said, okay, I can believe this report. One of them was my professor at the Ohio State University at one time. And the other one was a colleague from the same school, and he went on to do more robotics than I did. But nevertheless, I looked at that report. They did it in 2004, 2005, started writing 2006, started publishing 2007, 2008. So a little bit behind times, but that's all that we have on the whole world. Then with this, there was another addition to this report, but this was just a human-robot interaction. So it's sort of smallish because it doesn't take as much of a world, basically Japan, South Korea, China, and so on. So I didn't work with it much, even though it's relatively new. The reason it's relatively new and that we like it is because you'll see that again, that President Obama was claiming that we can all live and work together, robots and people. So he started some initiatives on we the people and them, the robots, will not take away our jobs, but will work with us collaboratively. So there's some initiative at National Science Foundation on developing and working on these problems that are dealing with people and robots together. And finally, there was a little presentation at the Carnegie Mellon about 2007-8, again by Tom Atwood, that I thought was interesting. It was in a robot magazine, so it's not as a high level, but still interesting enough to actually put it as a literature. I will copying from this shamelessly, but now I gave you that this is literature, therefore it will be there. Sometimes I forget my quotes, which I should put, and I'll let you know in the presentation where these actually fit. So first of all, we have a couple definitions of robots. Well, everybody can tell that these should be robots, even though there's an actor inside of one, right? Well, we went away from that. Now we have the real robots of that type. First definition is a mechanical device resembles a human and does some work. Okay, fine, resembles human. Complex human task programmed either in advance or commanded to do so. And the other definition deals with any mechanical device operates automatically or by remote control. And these two are straight from the online dictionary. I said, okay, what's a robot? Well, I don't remember. All my students are supposed to know that. And I said, okay, let me look at the dictionary instead. I don't ask you what a robot is. I ask what industrial robot is. So I looked up the definition and said, all right. So C-3PO looks like a robot. R2-D2 looks like a robot. Therefore, they must be robots. However, here comes a little bit of a problem with the definition when anything that operates automatically or remote control is a robot. We usually think of the lesser robots if they are operated by remote control. However, in a definition, they are robots. Then anything that operates automatically, well, it should move and do something, dance for us or so on. It should not be just a machine that has it's tied to a specific task. Like CNC machines should not be robots. Well, Japanese don't think so. They think they're robots, so they inflate their number of robots and technology in the country, claiming that they have more than we do and so on. In this report, not everything could fit. They started with about 25 different technologies, applications, and so on in robotics, and decided, too many. Let's put this somehow into fewer. Depending on who was in a committee, they pushed them in and put some of them together that don't quite belong, but maybe belong for them enough. So they said, all right, let's have 6 of these only that we will work with. So robotic vehicles, well, it's almost all the robots. Space robotics, humanoid robots, industrial service and personal robots, something in biology and medicine, well, the robots that cut you nicely, surgical robots and so on, and networked robots. I don't know how these networked robots jump in at the end, but I guess the people, 2 of them in the committee were the ones that pushed it. So they're in. But what's not really covered well are these others. The educational robotics is almost just a passing thought for him. Say, oh yeah, sure, I can educate with them. So show a couple of pictures. Environmental robotics, as it exists, cleans up environment, does this and that, good. Nanorobotics deals with, I will not deal any further than here, deals with robots of anything under millimeter size. They call them already nano, but that's really not quite definition of nano. A nanometer, because everything, some dimensions should be in a nanometer range, or they're calling them nano robots because they're dealing with devices or parts or anything else in that range. For example, your typical atomic force microscope can be considered a nanorobot because it does have a very precise portion that's manipulating atoms, well, sort of, something close to atoms. They're somewhere there in a nanometer range, and they do that in the 3 dimensions. Plus another piece that is bringing the a tool close and so on. So basically, scanning tunneling microscope, atomic force microscope, comes onto the nanorobotics umbrella. Basically, from my side, just about everything is robot. Nikola Tesla claimed that people are also robots because they're mostly mechanical devices with a little bit of chemistry sprinkled around and biology, that's it. So maybe we are, maybe we're not quite as much of a robots. We have the soul or not, I don't know how that works. Then there was not much talked about control software for robotics, even though a software is now more than 50% of the robotics itself. Sensor actuator networks were not talked about, where a robot actually takes and does something depending on the whole network of sensors out there. The human-robot interaction was covered a little bit in 2012 report, but not really that much. So finally, they didn't touch anything about hobby robots, the ones that you build and you play with and so on. They claim that's a sort of educational, maybe not. So what they covered were wherever they could speak, I guess, English or so on. Even Japan, South Korea, France, Germany, Italy, Spain, Sweden, so European Union. Even they went to, didn't quite go to Australia. They did a video views of their labs and so on. But nevertheless, good part of the world. China only one part there, so we have China missing, sort of, India missing, Russia missing. Well, we just claim that 2/3 of the world are not important enough for, they didn't have enough money. They just ran out of money because they were visiting about 30, 40 or 60 labs total. So they did have a lot of traveling to do this committee and so on. And then they said, okay, we decided not to do anything with a few more countries because we don't have the money. Now we'll start with the first one. These are robotic vehicles. What are they? Anything that moves around. So in various environments, ground, air, water, space, unmanned intelligent machines. That's just about all of the robots, but some of the others will fit in similar categories. Even the remotely controlled ones are robots. So we have UAVs as robots. We have toys for children robots, and so on. And they're all robotic vehicles. However, this remote control is usually the first step, but the autonomous operation is a next step for them, and it's much harder. It's much easier when you look and see what's going on and you move your robot there and tell it to go and do something. Well, we lead here, mostly because military robots, the Predator, Pegasus aircraft, submarines, trucks, Humvees, PackBot. I'll show them in a second. But before showing them, I'll tell you about DARPA challenges. There were 2 so far as I remember. Didn't check any new ones. The first one was going about 100 miles over a desert sort of terrain and have a robot do it autonomously without human interaction. So you have this big car, big truck or something, turn it on and let it go 100 miles. First time they failed miserably. The not so winner was the one that went a few feet or so on. The others didn't do anything. So that was $1 million prize. Then DARPA made it, said, okay, how about $2 million? All of a sudden there were more people and few vehicles actually finished. 2 from the same school went through and one of them won the money. Of course, $2 million doesn't go that far if you have 60, 70 students, graduates, undergraduates, few professors working on it year round and making it. However, that was a great proof that yes, we can have the robots that will go autonomously for 100 miles. Then when that was done, they said, oh, how about in a city? That would be a little bit harder, you think. First year, it worked. Few teams made it. Yeah, they were using special sensors to sense and map the terrain and so on, and they made it. So now we believe that we are still in the lead because of these DARPA challenges, and many, even private companies coming out and say, okay, $2 million, we can play. University beat them, so they are the ones that won. And finally, here will be some search and rescue. So let's see what these pictures look like. Of course, you have a lot of military. Here is the PackBot. This is sort of similar to what you have in Roomba. It's just a little bit different as far as the system for traveling, so it has tracks and so on. So basically like a tank more than a little Roomba that you would see cleaning your room. But then we have the Pegasus. A company developed it, a private group, and then decided, all right, since we are so good, we can sell it to the military. And the Predator, I had a choice of a few figures. One of them actually shooting a missile or so on. I said, no, it's too military-ish. Let's just not have it shoot anything, just fly. And so now one side, so this side would be the military. This side is search and rescue. This little robot has lights to see where it's going. It's good for different terrains. It has a camera somewhere in there, and so on.
Does the PackBot predate the Mars rovers? Because it looks like...
No. It's newer, actually. Because iRobot was not around for too many years.
Right. So they built it, ironically.
Mm-hmm.
The same company that does the robot.
Yes.
Okay.
Well, they diversified because at the beginning they were not making enough money, so they went to the military and they started because that robot actually is it's not a fighting robot. Mm-hmm. What it does is it has a part that can see a mine, right, go over it and I guess destroy itself or something for neutralizing the minefields and so on.
What does Pegasus do?
Flies autonomously somewhat. But I'm
recently take off the aircraft carrier, I think. The X-47.
It might have.
That thing, I was reading something.
I'm trying to remember what it did, but it was just it was an aircraft that is better looking, I guess, than the Predator.
Yeah.
And it looks like it has a stealthy features, should be, because there are no sharp angles anywhere, right? And I have few videos for you. Let's see if I can just click on this and run it, or do I need to do something special to it? Let's see the special to it. On this one is the rescue robots, so these may not be that great videos, but or may not even run. Okay. On this one we may not have a video then, or maybe none of them will do it. Oh, well. So at the moment, please let me interrupt this for a second and see if there is any way to actually get this thing down to. Maybe not. Okay, in that case, I'll tell you what our videos are all about. So in this first video, they're showing the a building that was sort of burnt and so on, and they're sending a little robot in it, and robot goes and shows that there is something, finds a person and say, all right, this was nice demo for this robot. And then they show that one of the Texas schools, how they're actually sending the robot with a video, but not a camera, but actually the TV or so on, so they can watch the news while they're waiting to be rescued and so on. I say, I wouldn't be really watching the news as it says, we cannot come get to them and things like that. The next two videos should be much the better. Let's see if we can get a chance to actually even come anywhere close to them, because the YouTube should be good and it should actually work. So let's see how what happens there. And this video should actually work, and it is one of the. Now the question: do we have the volume? What you see is a little quadcopter, and the guy is not falling. Don't worry about it. And a maneuver.
Multiple vehicles can fly as a formation.
I like you to hear the buzzing, but at the same time not to overwhelm it. Now, this is actually an amazing video. Look at how many of them. What is it, 20 of them?
We developed a method to transition between formations in 3D. The team can also navigate in environments with obstacles.
And look at on the side, it's a top figure where they're going in a figure 8. We don't know if that's actually true or how they did it, because they may have not programmed all of them, but one by one, and there might be hundreds of students there with joysticks and so on.
I think that would be harder.
Yes, but this is one, and let me see if we can have the part 2 on it. And this part 2 is actually even more impressive. I'm sorry, I'm just showing you some videos, but I think they're impressive videos. So there you go. Okay, that's supposed to be somewhere around here. Yeah, there it is. It's the sort of the same people, but let's see what they do now. This is incredible what they do with this thing. Oh, you've seen it?
time we show how two quadricopters work together to go and catch the inverted pendulum between them.
I couldn't do that.
A 6 centimeter ray is placed mounted on top of each quadricopter, serves as a supporting base for throwing and catching the pole. Shock absorbers attached to both ends of the pole dampen the impact when it hits the catching plate. As soon as physical contact is made, the quadricopter begins to balance the pole. The throwing maneuver begins with the quadricopter hovering at a constant position. By modeling the dynamics of the quadricopter pole system, we have identified a state in which the contact force between the pole and the quadricopter is zero, meaning that the pole will be launched off the quadricopter. An optimal open loop trajectory is generated to maneuver the quadricopter to this launch state and trap using feedback control. The catching quadricopter starts above the expected impact point and begins to fly down, while the other quadricopter throws the pole. As soon as the pole is in the air, the system predicts the impact position. In order to catch and balance the pole with minimum control effort, the catching instant is chosen such that the pole will rotate into the upright equilibrium position by itself. The catching trajectory is recomputed 50 times per second to end at the predicted impact position. Because the catching vehicle has only about 0.65 seconds to correct its position and catch the pole, we apply learning algorithms to the system in order to improve its performance over time.
I believe it is incredible what they can do, what they did with these.
Where is it happening? Where is this happening?
Yes, but I think this was somewhere, well, by the accent I think it's somewhere in Germany, but some of them are from here too, so let me just close these tabs and open them if we need them again. So, and now where we are at CSU-Pueblo, so we have this world view and all this great stuff, and we have robotic vehicles. If you walk in our building, you will see there's from different competitions. Even some people can recognize their own robots. Here's the one that actually has to go over that obstacle, so it's similar to some of the others. Then the others are in various disarray positions. Some of them actually work. Some of them never did work, like that one down there. And some of them are just toys on our side that we have built at one time or another. And here's one that Alex was building, which is our quadcopter, our own quadcopter that still waiting to take flight. But we are. Now we burnt a couple of things over there. It had a blue smoke of destiny and so on. It was not really healthy, but we replaced the parts. Now we just need to reconnect everything, and there is of course a great fear that we'll do whatever happened last time. Now we don't have any robots in space. We did travel sort of close to near space in some of our robots, meaning that a robot was dropped from a near space orbit or so on, but that was from balloons and such that we have the NASA money for every year. I don't remember how much money there is, but it's about $10,000 something, a little bit less than that, so that we have plans to play with these robots just for us, not necessarily to push the envelope of science and engineering in it. But in space robotics, basically, there are any robots that can withstand and work in this harsh space environment. We lead in there because we're the only ones that have the rockets to go somewhere, and nobody else does much. And we still have an impressive array of the machines, from Spirit, Opportunity, Curiosity, for Mars exploration rovers. They even have MER using the forum. And then there is a robot arm on Space Shuttle, so Canada is a player, therefore. And we have robonauts. Instead of astronauts, we have robonauts, and this is a version 2. First one had the wheels and stuff like that, and just torso looking like a human. The other one has everything looking like a human. So we'll see what some of those robots look like for a second. Well, that's the beginning, sort of, with all the goodies on them. And here is a curiosity on two figures. Well, one is the rendering of a not real, so basically it's just pretend. The real pictures were coming, and we have them, but they don't look as pretty as these, because there is no guy or anybody else to stand far away and take a picture. It's pictures are coming from the cameras and so on. Now this robot can actually take a sample, dig into it, grab and pulverize it, and put it through chemical analysis. In the labs on the chip or nearby, these are two labs. There's one and there's another one right there, so it can actually see what it wants to see, grab it and push it into these two labs and actually do the analysis of the soil. So it can dig in, can take the samples from a certain depth and so on, and it's relatively powerful as such. Of course, they have a lot of parts, as you can see, and this one is no different. Now we have the Canadians. Okay, I gotta put them in there. So there's their big arm helping and around on a shuttle, helping astronauts have a almost free walk. So they're sort of caught and moved around with this huge arm. On a side, since this is international, so we have Canada, now we have Germany robot that actually never went into real space. They had them above the ground, flying and so on, but not really, we never took it to a space station or anything else. And now we have robot now. So who do we send? The number one, number two. Politically correct, politically incorrect. If one dies, we stop a lot of stuff. If these guys don't function, we just build more. And we don't complain about them, except that they cost some money. So basically, let's see what I have on this one. As I said, I have a bunch of videos, and I hope you enjoy them. And this one is just the feed itself for that. Okay, again, it's a space flight and the robots are everywhere. There's a robot. I don't know why they left the robot on the ground. They're supposed to go into space. Yeah, we have to leave somebody to wave, right? Okay, I could always make it larger, I guess, but. And of course, it doesn't have real fingers. Since this comes from NASA, obviously they want the flights, and the robot is just secondary. But we think it's beautifully done. Okay, there is a... Okay, that's about as much of a robot. So this is robot in space. They'll be showing the... well, maybe I'll wait. It's just 2 minutes left. I have no idea who these people are. Okay, so we have the robots in there. And mostly NASA, but a little bit of robots.
So is that what's being planned to send robots to Mars? Or?
There are no plans to send anybody to Mars, I think, yet.
Well, I know, but I mean,
Unfortunately, we are not sending anybody. I mean, I guess there's no money for NASA. There's less and less money in general per year, or it stays flat or something like that.
no, I don't mean in practical terms, but that if there is.
Well, there is actually big. There is a Mars Society who wants to send people, and they're claiming that people should be going, not the robots. But on the other hand, whatever is cheaper, I guess, will win the race. And now back to the humanoid robots. There's a separate entity, but even though they're space robots and everywhere else, well, basically they look like humans, and we think they do something human-like. We are not in a lead because Asia is. We're developing a biped locomotion since the late 60s, well, mid 60s or so on, and they even changed things around on biped locomotion last a couple of years. Till a few years back, we had one rule, or one major rule that was tied to how robots walk, and that's tied to the heel touching the ground. When heel does that, it has a sort of a point of a zero moment, which is in there, everything turns over it, and they use that particular principle for many years. It was developed by one of my mentors, but then Japanese ran with it and were rather successful until a couple of years ago when they decided, oh, why don't we just use the human ears style and have that to actually tell us where the robot is, and use that for when they're walking and so on. And that was also successful because sensors became better than what they were before. Well, it's claimed that Japan has the largest humanoid population in the world, and they have most money in research for the humanoid robots. Somehow they like them, and here's one of them over there. It's relatively new. The idea is that the big companies are also players, which is not quite the case here. So let's see a couple of videos for humanoid robots. Again, lots of videos. I hope I'll be on time here, but we'll be relatively quick. It's not really a good video, so.
The Replicator has been developed for studying these issues by Osaka University and Colorado.
If you didn't notice, not the person that's a robot.
Required for generating human-like behaviors. The Replicator has 42 actuators in the upper torso and 13 actuators in the head. This is the most complex humanoid robot. And many sensors are installed around the Replicator. Furthermore, the body of the Replicator is covered by skin sensors. These sensors generate very human-like reactions and behaviors. So we are tackling several research issues by using these android robots. So first, how should a robot be similar to a human? The second, why do we feel uncanny valley as the robot is getting close to the human? And how do we develop more human-like behaviors for the android? And why do we become aware that is not a human? And it finally does a human unconsciously recognize a human. So we are studying what is a human by using this Android robot. Knowledge of cognitive science and psychology is important for developing more human-like androids. On the other hand, the android contributes to the human science itself. That is, the android develops a new research field, the interdisciplinary research field where the science and engineering are tightly coupled. That we call this field android science.
And more or less looking at the robot blinking, moving a little bit, singing. Okay, that is about the best part of it. That's better English than the professors, right? Okay, so it's a robot or some really weird human being. We have more stuff there on him, how she's actually singing and doing other things, but I'll quickly try to skip a few of those. And oh, it's not moving anymore. Okay. Now she's gonna show human behavior there a little bit. Okay, I think that's good enough for that robot. Let's go ahead and try another robot. This robot is actually, this is actually one of my favorite ones. So I said no matter what, this one has to go, even though it's a 3-4 minutes. How many of you have seen this video so I don't have to run it for long enough? Oh, then watch and enjoy. Of course, they're little robots. You can see the people beside them, so you can tell that they're not just people in robot clothing. Oh, we'll stop there with that one. They have some more, but let's just stop them a little bit here because I like this particular group. And now, in the last couple of minutes, we'll talk about industrial service, personal robots that are actually taking more and more of a market in the world. In general, the industrial robots are making things. It says industrial tasks, service are helping people. And the personal robots serve as educators, assistants, entertainers at home, and so on. Within industrial robots, that's a large market, but we are not first in this one. We started the industrial robot revolution, but we didn't get a chance to finish it. Most of the robotics companies are gone under, and very little is left in the industrial world. Basically, the companies are applications are not that impressive either. Material handling, welding, painting, and so on. And most of them are in Japan, and some of them in Europe. So we have Fanuc of Japan. It's about 20% of the world market already in one company. ABB with 1.5 billion in sales a year. KUKA also somewhere there. And here a couple little pictures of them attacking the car or fixing them and so on. You will see a lot of beautiful pictures of robots in factories where they actually sparks flying, everything going in on a TV and so on. And of course, we have some. And here are ours. So basically, we have the Motoman robot that awaits a $10,000 upgrade in software, supposedly working on the towers of Hanoi, and Cirrus Plus that sometimes works, sometimes doesn't, but it's still we have them, and we claim that's our robotics industrial setup. For service robots, it's also a big market, and it is relatively new, and it's growing. We divide in professional service robots, so in a workplace versus the personal ones. When you put a vacuum cleaners, entertaining robots, it gets 3.5 billion market, even on 5 billion total of all the service robots. And we have the manufacturers in Japan are big companies. They're not little companies like here, startups and so on. So you have Sony, Fujitsu, Mitsubishi, Honda, all in this area. And I decided just to show ours. Roomba is everywhere, but we have one around sitting in our lab, just so I took a picture of it. Then, since we were at the personal robots and education, we have oodles of Mindstorms, about 40 or something, I think, total. And here's the newest one that is basically our Danny K from National Instruments, plus the Kinect sensor. You can notice it's a relatively new one, I think, because it just came out in February, well, last year. It's not that new anymore. Biological medical applications, we are the leaders, and we are using for DNA sequencing or diagnostic surgery rehabilitation. So there's prosthetics in there as well, or the devices will go into your body and look around you. United States, we are leaders, and here is a surgical system. Well, not time for videos. We'll be done with videos. You can look at them. And here's how this robot looks, rather menacing, something from sci-fi movies. When you see that, there's probably aliens involved in that movie, but here it is, it does the job. And finally, we have a little bit of a network robots, and this is good about a portion dealing with cooperation between the robots to accomplish some tasks. We know how people should work in groups and work together, and here's the robots working together and so on. So again, I mentioned this the last year, President Obama wanted to do us to go get along well together, and we are leading in this area. Here are some examples of these robots. I know I'm out of time in about less than a minute. So they just load, okay. So as you can see, for example, these robots are reconfigurable. They put themselves together into something else. For example, if you take this one and that one get together, they can make something like this. Then we have some strange looking robots that are here. They're all white, sort of, and they also get into different configurations as well. With doing that, hopefully they can work together on problems and solve them if more than one robot is working. For example, if you're lifting something and one robot can do it, maybe 2 or 3 or 4 can do it, so they can all gang up on that part or so on and lift it. That would be an easy application. Then what you do with it after that is another set of problems. Or, for example, building a bridge over a river or so on from one side, other side, robots everywhere to actually make it work. So in general, the networked robots are a part of the relatively new way. A good part of our research is going in there. However, robotics research in the country not supported by the military, which is over $200 million a year, is about 10-20 million at best. So it's not really that big of an input in influx of money in the at the universities for NSF and so on. So other countries are slowly picking up the lag. Some of them are surpassing us in certain parts like humanoid robots or even industrial robotics and so on. But robots are everywhere. It's rather pervasive. A little device, you can see them everywhere. Anything that has control that moves, you can claim it's a robot. So that's on my side what I wanted to impart on you today. So it's one exciting field, and it's getting very interesting with all the artificial intelligence advances, with cheaper computers and power per multiplication and so on. So, and finally we have some robots. I didn't include the last picture of a robot that Alex and Shane were building, but it looked actually very interesting at the end. It was shiny aluminum, so it was shining in, coming out a door, looking like a Martian coming to Earth or so on. Okay, so we'll open for questions.
Google has some robot cars that run around. They go around with little cameras, and I saw one in California last summer, and they have a driver, but the driver is just there because the law requires him to be, but the car just goes and drives around and takes photographs for Google and all that sort of stuff. There's only been one accident involving one of those robot cars, and that's when the human was driving it.
Well, transportation is actually a good robotics application. The leads are not us in general in this area. We have European Union has actually planned and is claiming that it will have a car on the road soon that it will be selling and so on. I haven't had a chance to actually drive or be driven in one of them. Then Australia is big on transportation, but they're all mostly good in automated mining operations. So they send a robot to go mine whatever, and you come back, give us the ore and so on. So there's still a lot of work that is being done and will be done. But yeah, that's a Google car is a great example of robotics. I didn't get a chance to put it in. I'm, as I said, a couple of years behind on this particular report.
So we can hope to solve the Denver I-25 problem in some point with robotic cars, rather than everybody driving, changing, and use it.
Well, they might, but how I'm seeing is the claim is that the roads are over attacks. There's too many cars on the road, so maybe there's some other different solution that they will use. Even people from the railroad industry are claiming that soon they will be the heroes to save the world, because there'll be too many cars, trucks, and everything else on the roads.
Can I just ask, because I'm very naive, but so this amusing video, the robots for entertainment, I guess. So how is it, I mean, are those all the movements programmed, or and they're identical?
We are assuming that they have a network and that they're communicating, but we don't know.
I see.
They didn't tell us. They just said, here's the video, it works, and all that stuff. And since people are working, we know that it's not just making one and then try to change it and so on. It doesn't look like it's a video trick. But they've done quite a bit of work on inter-robotic, which is basically just the computer-to-computer communication, wireless. So there must be somewhere in there the lead robot that has everything and the others are following, but the delay is so small that we don't see it.
So other than making these videos, what else do they do with those robots?
Oh, for example, one interesting application is actually some autistic children will relate much better to a robot than a human being and take him as friend. So it has a face, everything else, it talks back and forth, and it answers questions, and as such, works better than humans. Also, they can use, now we have a good part of the robotics that's dealing with helping elderly. That a group is the one that will be using robots more and more for, let's say, helping them bring the coffee, to washing dishes, to actually help them get out of the bed when they need to change the bedding and so on. So it is an exciting time for robots. I'm not going to say they're taking over, because that's just a philosophical conjecture at this time.
Yep. Did you say that there's going to be robotics at the Mars Society meeting?
No, the Mars Society is anti-robotics, I think.
Oh, really?
Yeah, they want to send people.
Oh. They're meeting in CU, I think, aren't they, this summer?
I don't know. I know we have our delegated Martian, which is Hussein, to go to all the meetings and fly up in the air, and we actually are putting up the money to get him to Mars. He said, I don't have to come back. So since that trip is 2 times more expensive, we are fine with that, but still there's some money involved. Needs to lose some more weight that we can actually afford it.
My question was about, because I'm thinking who's going to volunteer to go to Mars? But now you answered that question.
Oh no, there are many volunteers. You don't worry about that. There's about a good chunk of population that will go without looking back.
I heard on the radio today that there was somebody, a very wealthy guy, who's offering a whole bunch of money to send a couple to Mars and back. I mean, it's just like he's going to take it. No, just find a couple that will take $1 million or something like that, and fly them to Mars and come back. So
That's not exactly the full story.
Oh, what is the story?
The entire story is the guys funded the project. It's about $1 billion project to go to Mars and loop it and come back. And because it's a 501-day mission, they would prefer a couple. They think they would get along better.
okay.
Oh, they prefer.
Yeah.
I'm not so sure about that.
See this scar?
Yeah.
That's right.
But the guy's he's got an actual craft. He's funded the project.
Okay. Thanks.
So Hussein can talk his wife into it.
Well, that's the hard part.
So you showed that video of the robot being launched into space. Where were they sending it? What's happening with that?
Well, the next video that I didn't show you is from the same group that shows the crew and an extra crew member, which is a robot. And says, okay, we're all going, so the robot will go with the rest of the crew. And the major idea behind this robot is to actually be able to use the normal human interface. When you press the button, push the button, press the switch, things like that, or toggle it and so on. And they have proven that that can be done. The robot can do all this. So with all the normal human interface, it can actually do and work in space along humans. And that's been simulated already, so they can show the robot can do it. But the question is when and how next launch will be for the robot. It's a robot is now it's in a second version.
Yeah, about the robot.
Go ahead.
Okay, so about the Robonaut 2. If I remember correctly, the first one was just teleoperated, just the remote control. Is the second one autonomous or semi-autonomous, or how's that one work? You know?
I think the second one had more of human legs and so on. So it was like a biped, could actually walk versus being on wheels and such. Because the other one was like a centaur, more than a, more than a actually humanoid. And as such, couldn't go in space. It couldn't do the same stuff as human.
Like a rover type thing.
Yeah, a rover type with a human torso and a head. But this one is not. So that's why it's a Robonaut 2. I don't know if it's autonomous. What I've seen was autonomous, but that was on Earth and so on. So I'm not sure how that will work up there. But remember, if you have to send somebody outside and you stay inside, anybody, so just go get a robot and do it. Even if you have to look through cameras and see and press the buttons and do whatever you need to do.
Yeah, it's, if you're doing an EVA, that spacesuit has an interesting property you don't think about, but it's that when you move anything, your arms, your legs, your hands, your fingers, anything like that, the volume of that suit must remain constant. Otherwise, you're doing work against something like 15 pounds per square inch, and it gets really rough. So a robot could go out there naked as a jaybird and not be encumbered by that spacesuit. I just made that up.
But it's true.
True.
So no need to suit up.
Yeah.
Just launch the robot.
And get him out there quicker than it takes to get an astronaut to do that for an emergency repair or something too.
Hopefully, hopefully.
But this hasn't happened yet. I mean, we haven't launched it yet.
Oh, no, we haven't launched it, but we tested it.
So
They're there, they were built.
made up.
They exist. The robot does exist.
Okay.
It is not just on paper, and
Okay.
it actually does exist.
We don't do
At least I believe it exists, because I saw people in another video how they're actually they're putting pieces together and everything else. So as much as my eyes can tell, that's true.
So let's thank our speaker
Yeah.
again. Oh,
Okay, thanks everyone.
Job done good.